So hello everyone, it's May 25, 2018, and we're here to get a sprint demo for the sprint number 5. Today we'll have a presentation starting from Pavel, talk about open tracing, and then Joel, and then Kenya. So this meeting will be recorded and put on YouTube. It's public, so anyone can attend. And if at the end we have some time, we can also stop the recording and answer questions. But anyway, Pavel, you can go ahead and share your screen.
So hello, I assume you can see my screen?
Yes, I can.
Yes.
Yeah, I will tell you something about MicroProfile Open Tracing, what it is, and also a short demo in Wi-Fi Swarm. So MicroProfile Open Tracing, there are basically two main features. It allows you to automatically trace your Java EE stack, and other feature is that it exposes Open Tracing API, so you can use it explicitly to create some spans in your business logic. For the Java EE stack, it traces JAX-RS endpoints and also client invocation. There is only one API directly in the microprofile, which is traced annotation. It's used to disable JAX-RS endpoints, to disable tracing, of course, because tracing for the endpoints is automatically enabled. And it's also used to enable tracing for CDI beans. And then there is the second parameter, which is name, and you can use it to override the default operation name for spans. So every span has an operation name, which is usually like a class name or a HTTP path. So you can use your names to more easily query the spans you're looking for. So then there will be demo. So I'm not sure if you know, but Wi-Fi Swarm was renamed to Thorntail. And here's like a picture of that bird. So this is a very simple Swarm app. It uses only two fractions. First one is JAX-RS, second one CDI, and also MicroProfile open tracing fraction. As I said, MicroProfile automatically traces some endpoints, right? But I didn't mention how you can actually configure the tracer because it uses open tracing, so it is vendor neutral. So in the Wi-Fi form, it's of course implementation specific. So we use tracer resolver to get the tracer. So tracer resolver is just a simple interface where you can implement it, then it will resolve tracer from the class path. So let's look at the application. That's a simple JAX-RS app. This is the endpoint class. There are several endpoints. The first one is just get on the root path. It returns some string. Then there is a pigeon. It returns some string. But there is also traced annotation, which overrides default operation name. The second one is half endpoint. Interesting is that it's disabled. The tracing is disabled. It's very useful to use it for half endpoints or some endpoints which you don't want to trace. Then there is a chaining. Chaining is a little bit more interesting because when you call it, it creates a client, and the client calls the first root endpoint. So there is a chaining between endpoints. As you can see, when I'm creating a client, actually client builder, I'm passing it to the client tracing register. It's important to do it because it will basically install all open tracing filters and potentially more required interfaces to allow you to trace client invocations. This is required, but MicroProfile implementation may decide to basically implement it directly in the client builder, so you don't have to actually call it. Okay, so I'm going to compile it. Compiled. I'm going to start Jaeger server and start the. Oh, sorry, I stopped sharing. I wanted to hide. Okay, so I'm going to start the Swarm app. You may notice there is something like Jaeger service name. This is required for the tracer resolver, and it's because Jaeger tracer requires some parameters to start the tracer. There are, of course, more parameters, but we use all default one. Okay, so it started, and I can invoke the root endpoint. So it returns some string. We go to Jaeger UI, and let's look at the trace. So we can see the service name, the operation name, which is HTTP method, and then the package name, class name, and the method name. The MicroProfile adds some tags like the component, server. These are related to the Jaeger tracer, URL, and the method. So let's try the other one. Let's try the pigeon. So pigeon, we can see there is no pigeon. There is actually stock because I use the traced operation name stork. So we can call also the hello. A couple of times. There are no hello. There are no traces for a hello endpoint. We can call the chaining. There are three spans. The first one is for the chaining endpoint. The second one for the client invocation. You can see the same kind is client. And the last one is for the server side of the root endpoint. Okay, so this was tracing for the JAX-RS endpoints. And then the second part is tracing for the CDI, or so-called explicit tracing. So I have two services. The first one is just a simple bean, one method. The other one is almost the same, right? And there is a method. The only difference is that I use traced on the class level, and I'm also using it on the method level to override the operation name. If I use it like this, the operation name would be package name, class name, and the method. But you can specify the operation name to make it nicer. Then there is a service endpoint, and there are two endpoints. The first one is for the not traced, and the second one is for the traced. So we can call services. This is not traced. It's just the root. And the second one should be traced. We return the class name. So it should be this one. This is for the not traced, and we can see there is one span which is for the endpoint invocation of the JAX-RS, not for the invocation of the bean method. The second one is for the traced, so we can see the endpoint, then the service method. At the moment, there are no tags. We don't add any metadata to the span. In the future, we could, for example, log exceptions if there are any, or I don't know, do something with the parameters. And then there is a foo, and foo is a span created inside the method. So you can get the tracer, you can inject it, and create any spans you want. And everything is correlated together, so you can see nice tree of your invocation. So okay, this is pretty much everything. You can find the MicroProfile Open Tracing repository on this URL. There is also a section in the MicroProfile ebook, and my code is not available because it was merged only today into Valflies form, and I will probably push it into the Valflies form examples later. Okay, thank you. If you have any questions?
So let's move to Joel. There are questions. We can see that at the end.
Yes, okay. So let me share my screen. Okay, you should see it. Some new stuff on the Kiali console. What we added in the service details view is some validation of the root rules and about the YAML from Istio. So here I already have deployed the bookinfo tutorial with some root rules, and you can see that there is this new view here, this table, which show the stages, the labels, and the weights. If I go to a service that have several versions here, I see there are both of them, and no problem at this step. You see here the weights of each rule. So it means that the traffic is redirected 50% on version 1 and 50% of version 3. And now, if I go to the OpenShift console, for instance, I am in the other resources, and I'm seeing the root rules. And if I edit manually the YAML, here I put something that is non-consistent, because Istio asks that the sum of weights must be 100. I save it, and here you will see that the weight sum should be 100. So you have this validation that comes here in Kiali. Another possible difference is if I put like -1 and 101, so the total will be 100. But here, as you can see, it's each individual lines has a status icon reporting an error. So the weight should be between 0 and 100. There's also some validation that is done on the precedence, since it must be an integer. So this validation is interesting because there are several ways to edit some root rules, and going through the console or direct YAML editing is one possibility. If you go with the istioctl command, it will run the validation, its own validations. So like here, okay, I think, sorry. You can see that it has another validation that comes with the istioctl command. But since there are several ways, we have this separate validation in Kiali. The second thing here in service details, so there are, it is supporting the new API of Istio. So there is the virtual services, which is more or less like a root rule, and destination rules is more or less like destination policies. So we can see both old and new API objects. And the pods is now something new. Before we had only deployments to see the Kubernetes deployments. And with pods, we have a better view of the runtimes, because pods could be deployed without a deployment object, like OpenShift brings the deployment config. And this is something that is currently not shown in Kiali. So it was important to show really what's the pod runtime. The pods shows the different labels associated with the created at timestamp, the created by, so it's the information about what created the pod. In that case, it's a replica set. And also some annotations that come from Istio are displayed here. So if this is a service that has Istio sidecar, there are the Istio init containers that are displayed and the Istio containers. It's important. It can be a very valuable information, because here you can see the version of Istio container that is deployed, and that could be one way to check if you are running what version of the API is running would be correct with these containers. And final thing is Istio config. So if you remember previously in Kiali, it was named here Istio mixer. Now it's Istio config. There are more things displayed under that screen. It now includes all the root rules and the Istio rules, the different Istio rules. So there is the filter capabilities here, where you can, for instance, filter by Istio type and say, I want all the root rules. And you can combine filters, like saying, I'm just looking at the book info namespace, and I want all the root rules and all the virtual services. So we can combine filters, and it will add everything that matches these filters. Here, for instance, I can see that I have a virtual service and the root rules for the same service, which means that it will be okay for both old and new API. And still, as always, you can sort by namespace, sort by Istio name, etc. And I think that's all for now.
Thank you. Next is Kenya.
Okay, let me just share my screen. Can you guys see it?
Yes.
Okay, cool. So today I'm going to present what we did on the last sprint on the Team Saturn. Most of the work is towards redexification and everything. So that means that some of it's not going to be presented to the user, but it's more like an internal organization, so we can deliver stuff faster in the future. So the first thing that we did have on this sprint is the test mesh, that we improve it. So actually now we can have test meshes that have an infinite number of services, an infinite number of versions of the same service, and they do connect to itself. So this is a screenshot I took from it. I am not going to show that live because my machine cannot handle that number of pods at the same time. So, okay, next thing, we're doing smoke tests using a proper browser and connect to the application itself. And Viet's going to talk a little more about this after this presentation. We are now Kubernetes ready. So that means that you can run Kiali on Kubernetes. It is not as supported as OpenShift is because most of us use OpenShift to do the development, but it should work. And if it doesn't, please create an issue. Okay, and here's a graph where all three of those servers have no sidecar. So that means that we can show the servers even if they are not in Istio anymore, if they haven't been, or if the sidecar is down. So it's always going to be there. And now if you remove a service from a mesh, it's not going to appear on the graph anymore. So let's do exactly that. So we deleted, and now let's just wait for it to get updated. That might take a little while. While that happens, I'm going to present everything else. So we now show latency data on the graph. So the percentile of the latency and how much it varies. So that means that you can catch latency variance a lot easier. And also while I'm this, we have other labels for the edges. So the number of requests per second, the percent of the request percent going to the same server with different versions. So as you can see, 18%, 14%, 18% is going to different versions of the same service. And here's the latency percentile. We can also have filtering, so we can show circuit breakers. So you have one here. And you can disable and show them here. You can also hiding the missing sidecars. Here is request percent of the total, so you can see where everything is going. And filtering, same thing. And we now have a message center that shows if things go down. So let's do exactly that. Let's just drop Kiali down. Running. Let's drop it. And let's see what happens. So we have the pop-up message here, but the errors are also going to be shown on the message center. And that happens with all errors that we show on the service graph. So that means you're never going to lose another message. So yeah, and that's it. Do you guys have any questions?
All right, thanks everyone.
Thank you. Viet's going to talk now, I think.